Before we jump into things, we wanted to share a few notes from today's webinar. If you need translation captions during the presentation, click the CC button at the bottom of your screen and change My Caption Languages into your convenient language. If you're having technical difficulties, the first thing you can do is leave the webinar and rejoin. You can type in the chat, otherwise we will try to help. You may ask questions in the Q&A chat at any point during the presentation, and our presenters respond to them during the question breaks. Today's webinar will be recorded and uploaded to RRCA's YouTube channel. Before diving into the main session, we are excited to start with a few words from WWT and RRCA. To get us started, I would like to invite Mr. Connor, the International Engagement Officer of WWT, for the opening remarks. Connor, the floor is yours.
Thank you very much, Aram. I'm delighted to be here, everyone. My name is Connor Walsh. So I work for WLI Global in my role at WWT, and I work with the head of WLI Global, Ms. Tina Redshaw, and I'm here to give her apologies. She really wants to be here to give you this message, but she is traveling at the moment, so she can't. She also wants to give big thanks to Mr. Suh, to Songbo, and to Aram there at Ramsar Regional Centre East Asia for this great webinar preparation and organisation. We're looking forward to the topic as well. Wetland monitoring and technology is a really interesting one. And we're also always going to be thinking about how the technical side of things can also relate to the SEPA side of things, how we can use it for engaging landowners, people in schools, local communities, everyone. And that's something that we can look forward to discussing maybe in the open forum. I will be here for the open forum as well. And I'm looking forward to hearing what you think about those topics, what inspiration it gives you. With that, I wish everyone in the webinar all the best of success. Have a lot of fun. And I will hand you back to Aram now. Thank you.
Thank you, Connor. Next, we are pleased to welcome Mr. Suh, the Executive Director of RRCA, for his opening message. Mr. Suh, you may begin.
Hello, everyone. It's been a long time since the last WLI Asia-Oceania conference in Sri Lanka, almost a year. It's pity that I cannot see your faces, but I can see many familiar names in the list of participants. After the WLI Asia-Oceania conference, we've been planning to do the programs to provide for the members for this year. I mean, it's been quite late. It's June already, but Arum and Songbo, they did a survey for the members of WLI Asia-Oceania, and then we picked up the themes and topics from there. So like technology. Advanced technology for the monitoring, that was one of the concerns of wetland centers. So that's why we invited the valuable speakers here, and we will learn more from them. And also we have prepared the networking session. So if there's anything in your mind, so anything you expect from the WLI Asia-Oceania network, then please feel free to just mention, tell us what you need. Then, of course, we have a limited budget, limited human resources, but I guarantee that we'll do our best to help you. I mean, to work with you. And please enjoy your webinar here. And later, my colleagues will update you how many webinars we are planning to, but there will be a series of events for the WLI Asia-Oceania members. So please enjoy this program. Thank you.
Thank you, Mr. Saw, and thank you again, Connor, for your remarks. Your message gave us a very good starting point and set the stage for today's webinar. Now we are ready to begin the main part of our session. We have an exciting lineup of speakers to share their experiences with us on wetland monitoring and technology. First up is Mr. Ivan, who will talk about smart wetlands monitoring technology using Internet of Things at MIPO. And moving on to the case study session, we will hear from Professor Ivy about using citizen science as a monitoring tool. Finally, Dr. John will present a case study on drone technology in wetland monitoring in New Zealand. Please leave your questions in the Q&A chat if there's any. And so let's get started. Ivan, you have 30 minutes. Please go ahead.
Okay, thank you. Is that the sound all right? Everything all right? You can see our screen here, right? So thank you for inviting me and our organization to share something what we are doing in our wetland in MIPO Natural Reserve here in Hong Kong. So I hope that we can bring some insights and something to everyone here. So let's get started. So sorry, let me allowing us video first. Yeah. Okay, so in case of someone not knowing where is MIPO and where is our natural reserve, so I put a few maps here. We are located in South China and kind of in a northwestern side of Hong Kong. It lies in the east coast of Pearl River mouth and at the mouth of the Shenzhen River. So we have quite a lot of discharge coming from the nearby water body, and the water is actually quite a lot of sedimentation and siltations here. So it's kind of a brackish water environment. And here, zooming into the Inner Deep Bay area, actually we are within the natural reserve is kind of fall in the core area of a bigger Ramsar site here, which includes a bunch of fish ponds and mangroves and a large flat area. So this is very important ecologically for MIPO and Inner Deep Bay because it regularly, annually, it supports over 60,000 waterbirds every winter. So this is kind of an important feeding and resting ground for the wintering and migratory birds. And also it supports a number of globally threatened species, including the Becky's spoonbill, Norman's green shanks, etc. And to some of more background about the natural reserve, it is not very big in terms of a natural reserve in other scales in other parts of the world, but it is very big in terms of Hong Kong scale. So this is 380 hectares, and it's established over 40 years ago, and almost since the 1983, and is managed by WWF Hong Kong here since then, and then it consists of quite a number of gateways, which is traditional stream points and some ring-fed points. And it consists of diversity of habitats. It consists of gateways and fish ponds nearby, and you can see some of the reed beds and freshwater ponds and mangrove forests. This is the biggest mangrove forest in Hong Kong, and outside the mangrove forest is the intertidal mudflats. So here we have management goals. First of all, of course, to reserve the biodiversity, to conserve the biodiversity here for the migratory birds here. And then also through active management, we want to sustain the practice of gateway as a traditional wise use of wetland. And also, we want MIPO to serve as a regional center for knowledge and awareness and knowledge exchange, and a center of those events. And so we every 5 years we will have a management plan. We have a management plan for to how can we achieve these goals, and what should we do to achieve these goals. So in the management plan, we have divided the MIPO as several biodiversity management zones. Most of them are for water birds. For example, the biodiversity management zone BMZ1 is for black-headed spoonbill and ducks, and some are for the reedbeds associated species, and some are for dedicated for the education programs, like the number 4. And I want to highlight here is the number 5 and number 7 is the shorebirds. We dedicated for the shorebirds. That is the high tide roost area for the shorebirds, for the water birds. So I will talk about it later when I go through my slides. And here we have some different focus on the conservation targets. For example, some vulnerable species and endangered species, and some locally threatened species such as the Eurasian otter, and one of them, the jellyfish, is the endemic. So far it's still endemic to MIPO, but we thought there should be somewhere else we can find the jellyfish. But it is also new to science recently, so yeah, we will keep monitoring these species and their numbers. So in terms of wetland habitat, actually we can broadly divide our wetland management efforts into two main categories. That is the wet part and the land part. That is the hydrology management and the vegetation management. I'll go into some more details soon. So in the water management, hydrology management, I would like to introduce the hydrology of the brackish gay white here. So actually the water is come from the outside, come from the deep bay area, where come from the mudflats. So it's all the way coming in from all the way from the mudflat through the water channel to a gay white sluice gate in number 2 here, the yellow spots. You can see the sluice gate in the bottom left-hand corner. The photos here, it is a concrete structure that allows us to control the water flow of the gateway coming in or coming out of the gateway. So there is a water channel connecting the entire gateway from the seaward side to the landward side, so that this is about 1 kilometer long, and this collecting all the water body from the western to the eastern side. And the sluice gate actually control the water level and control the water flow of the gateway. So when we open the sluice gate, when the tide outside is lower, and then we open the sluice gate, the water from the inside the gateway will go out. But vice versa, if the water is higher, if the tide coming in and the water is higher outside, and then we open the sluice gate, the water will go inside to the gateway. So that is how we control the water level and control the water flow of our gateway, of the gateways. Yes. So periodically, we will carry out the water exchange for the gateway to keep the water quality okay inside the gateway. So because otherwise those water will be just stagnant water and not good for wildlife. So we'll monitor the water level daily, and then traditionally we do this water exchange twice a month, which follows the lunar cycle or the tidal cycle. And from each round of the water exchange will last for 4 to 7 days. So you can see the field staff here manually open the wooden removing the wooden board, or just putting back the wooden board here to control the water flow here. So because it's quite large in the reserve, so they will use a bicycle to move from here to there, and then to open and close these sluice gates. So another water management is that we will have a scheduled drain down from for each of the gateway one by one. This is different from the water exchange because it will allow all the water go out of the gateway. So almost all, not entirely all, but as much as possible, we will drain down the gateway, so that this drain down will attract water birds to use the gateway area, because they can stand within the gateway. And then this also attracts a lot of egrets, and including the water black-headed spoonbills. They will use this kind of drain down gateways as their food source and their resting ground. So this will last for up to 10 days. So another water management is that we need to control the water level very precisely over the year, to allow us to control to optimize the area that provide the roosting ground, provide the high tide roosting sites for the shorebirds, because it is like this. The water birds will use the mudflat outside our natural reserve, but when the tide come in, they will have the water will be too deep for them to stay in the mudflat. So they will move inside to more landward side. So this is where our reserve serve our purpose. That is the high tide roosting sites. So when the high tides come in, the water birds will move into our high tide roosting sites here in the red box here. So because they have different shorebirds, they have different lengths in their legs. So we have a very shallow incline topography to allow them to stay in our gateway. So for the habitat management, and another part of habitat management, we have the land side, more landward side management. That is the vegetation management mainly. So actually, for the vegetation management, we either cut them by manually cut the grasses, or we use some livestock such as buffaloes to help us to graze and control the vegetation. And also we use the prescribed flooding here to another control of water level in the gateway to serve the purpose of vegetation control. And so today I will highlight the buffalo grazing and the prescribed flooding here. So here I just gave you some more background of how we're doing management, and then later on I'll touch on how technology help us do this management. So if you're frustrated why we are talking about this. So here we use for now, at the moment we have 14 buffaloes distributed in 2 enclosed area within our natural reserve. So they are really helpful. They help us to graze the grasses. They help us to control the vegetation. They help us make some muddy puddle inside the natural reserve, and which the cattle egrets and other birds, wetland birds, really like the habitats they create. So they are really helpful. But then in our wetland management and monitoring, actually we are facing a lot of constraint and challenge, like everybody here in wetland management. For example, we have limited access to electricity and network and internet network, and some of the locations are really remote and distinct area, and some of them are really inaccessible or very difficult to access. And also, we, like everybody else, we face the climate change challenge that which the climate change will induce the extreme weather, like the heavy rainfall, that because, for example, if we want to precisely control the water level, and then suddenly a heavy rainfall will affect our water level, will bring water level too high, and at the other way around, if there is a prolonged heat period will lower the water level too much. So, and also we have a labor shortage and manual effort limitation, and like we are very hard to hire some new blood in for the field staff to open and close those sluice gates. So so that's why here comes where we want to use some smart technology to help us manage and monitor our natural reserve. So we a few years ago we kickstart our smart wetlands initiative in order to help us in order to enhance the ecological integrity and resilience of the micro wetland, and mainly use the smart technology and the sustainable to practice, and also to conserve the biodiversity and the essential ecosystem service here. And actually, there are quite a lot of opportunity or areas or aspects that we can work on or to incorporate the smart technology into different areas. For example, like the habitat management, but also the physical experience and also the security and enforcement. We can incorporate smart technology into different aspects. But because of time limit here, I just focus on those habitat management and those research and monitoring area. So a few years ago, we started the initiative, and then we have our first funding from the government fund program to support our very first smart wetland project. In this project, we want to tackle some of the challenge and want to elevate our management effectiveness. And also we want to serve as a proof of concept that this is applicable in a remote area, in the countryside area. So again, some more background information. That is what is, in case somebody don't know what is the Internet of Things, the IoT. Actually, everything can be IoT. It's everything that, for example, your Garmin watch is the device that connects to your iPhone. So it has a device layer is your watch, and then you connect to the iPhone. That is through your Bluetooth signal. So that is the transmission layer, and the Bluetooth is your transmission layer. And then you open the Garmin app on your iPhone. So this is the application layer. So everything that like your device layer and connect to an application through a transmission layer, that can be called an IoT. That is a very broad definition of IoT. So for example, here in our smart wetland project, we have the first smart wetland project. We first installed quite a number of water level sensor and 2 sets of water quality sensor and 2 sets of buffalo tracking device. Through the connections of the LoRa gateway, that is more like a low frequency Wi-Fi. You can imagine that that can be transmitted a very long distance. but the setback is that it only can transmit very simple information that you cannot transmit very complicated like the image or like the photos or videos that it cannot has the bandwidth that broad enough to carry those information. So that is perfect for the device here, the LoRa gateway, and through the application we create and design our own central management system that hosts all the data and when we receive all the data, we visualize them for all the sensors, all the water level sensor, water quality sensor, and the buffalo tracker here. So first of all, the deployment, we have deployed the water sensor in our gateway. Actually, we have 21 gateways that is managed by us. So we have 21 over 20. We have 30. Actually, we have 30 water level sensor here installed everywhere in the natural reserve, and one of them are in the mudflat near the edge of mangrove. We have to install. We have to create our own supporting structure for the installation, and then we have to level them and calibrate the water level and to chart datum, and then we have that is relative to the sea level, how high is our water level. So we have to calibrate them, and then we install them to a height that is not flooded, even if the most extreme weather hit us. So it is installed to a quite a high level here. And so you can see, actually there are quite a number of challenges that we face when we install these water level or we use these water level sensors. But one of them is that when we install the water level sensors here, we first time we didn't install properly, so that the structure underneath is blocking the sensors. So that you can see here on the left hand side, the signal is blocked. The sonar is blocked by the structure underneath. So we have to adjust the installation position to further out to avoid the obstacles, and also you can notice that at first we use a wooden board or horizontal wooden board to attach to the water sensor here, water level sensor here, but then afterwards we change to a metallic bar for the installation, because this is because the wooden board will have such a fluctuation that when it experiences the heat, when it is the sunlight come down and hits the wooden board, and then it will expand so much that it affects the reading of our water level sensor. That is, the water level sensor is very sensitive to this kind of wooden board expansion, and so we have to change the material for the installation. So this is one of our challenge for the water level sensor. And then in terms of water quality sensor, we deploy them in the one inside our gateway and then one outside in the mudflat, also near the mangrove area where we have a floating bird hide there. So this water level sensor, when we install them, and then we have another challenge that is the biofouling problem, because the organisms that will grow on any surface, they will grow on our water quality sensors that is blocking their functions, so that they cannot properly sense the water quality. So we found a solution that is we have to install a couple mesh ripe mesh wire ripe to wrap around the water quality sensor, so that the biofouling would be there would be less biofouling over time. But then we still have to increase our maintaining frequency to check whether there is a biofouling after this improvement. So this is one of the challenges. And also for the buffalo tracking device, we install into we use a collar to fasten them in the neck of our buffaloes. One in the 17B and one in gateway here and 24 here. So they would receive signal from time to time to show where the buffaloes are. But then when the buffaloes are submerged underneath to the water, they cannot transmit any signals because the LoRa here we use is a very low transmission penetration power. So actually this problem, we still don't have any solutions. This is not resolved yet. So maybe perhaps in the future, we will explore to use another tracker that use another deployment method, like to attach to the ear or to the buffalo's horn, so that that will be a less time for the tracker to be submerged underneath the water. So for the central management system here, we have we visualize our data. We have an overall view of the sensors, and we visualize the water level signals, the water level set data and water quality data, like the temperature, the dissolved oxygen. And also for the buffalo location, we have a live view here, and also when the data is collected, enough data, we can create a heat map for how frequent they are using which area. Yeah. And also we have an alarm system that, for example, when the water level is not within our design, within our optimal level, the system can send us an alarm that so that we can look into the problem and whether to act on the problem or not. And also we compare this kind of smart monitoring to the traditional monitoring efforts. So how can this how is this more effective? So when we compare the traditional monitoring method and to the remote monitoring method, we because of manual power limitation, we can only have maybe one reading per day or one reading per month, and so on. And we have quite a number of sampling points, and that is very time consuming for one conservation staff to work this out. But then if we have this kind of IoT monitoring, we can have remote monitoring, and this is automatic. So they will send us data from time to time. For example, 15 minutes, every 15 minutes, we will collect the water level data, and then it can be 24/7 automatic data collections. And then we can have much more data available, and much more data available for more detailed analysis here. So this is some kind of conversion of how much increase in data frequency, and this is quite a lot number. This is when we do this kind of conversion, and this is how much mandate when we compare to the same level of if we want to manually measure this kind of data 24/7, how many mandate we have to deploy, and then we compare to the smart technology. They save us a lot of time to collect such amount of data. So yeah. So but then how can this kind of increase of data frequency, how can the increase in this data collection by IoT help us in management, and what can they do for us actually, like how can they help us? So we come back to the wetland management. We have hydrology management and vegetation management. So I'll break into details how this kind of data can help us in this management. First of all, these kind of data, when we collect so many data, we can check whether all the intended management actions are carried out. Like if the water exchange twice every month, whether it is carried out or not, and whether it is within the desired range, and we can just check the IoT data and visualize all the data for us. And also, we can check if there is any unexpected changes in terms of the water levels. Like when we have the prescribed flooding here, we want to push the water level as high as possible. Like, for example, to over 2 meters here, or to more precise 1.95 meters here. But then if it is dropped to a water level that is too low, we can inform action. We can react to this kind of low, non-optimal water level, and we can push further up. Like for example, here you can see it's dropped to a level that is too low. We have to push back up the water level to as high as possible for the vegetation control. So another example is that we have a rice paddy trial in one of our small a pond within our reserve. So before the IoT deployment, the IoT application here, we have when we have extreme weather, when we have heavy rainstorm, we have a delayed response because we have to only can go back and check the water level after the rainfall. And sometimes we fail to control the water level that our crop will die, our rice paddy will die, and then lead to the crop's failure and unable to maintain the paddy field as a habitat for our target species, like the yellow-breasted bunting. But after the IoT solution, we can monitor the water level remotely and continuously, and we can make early decision and whether to respond to the changes, to respond early, and we can have a more precise water level control. And so that our habitats can create a favorable habitat for the targeted wildlife here. Our target is the yellow-breasted bunting and the greater painted snipe here in the rice paddy. So in terms of the buffalo tracking, we don't when you have the real-time data for the buffalo location, they usually stay together so that even though we install the tracker on one of the buffaloes, we can locate the other buffalo as well. So for example, this is a view when we check the buffalo, the pond where the buffaloes are. So this is when we have to spend some time to look for them when we don't have the data in the office. But then if we want to go and check them, we can check the location first, and then we can go to locate them very fast, very quickly. And then another application is that we can use the water level data and correlate them with our shorebird data. So because we count the shorebird from time to time, actually twice a month. So and then we can correlate the water level sensor data to our shorebird data and to check whether the shorebird our water level is okay, is ideal for the shorebird to use our high tide roost. So from our data, like this is from the data in from April, the spring period, which there's a lot of shorebird using our the area. So this is one of the main high tide roosting area. So we control the water level at a very ideal level, that is the about 1.5, 1.6 meter. So there's quite a number of shorebirds using this area, 4,000, over the 4,000. And then in the other high tide roots area as well, we also have quite a number of shorebirds. That is quite decent number as well. But then if the water level is too high here, 1.65 meters is already, so we know that 1.65 meter in this area is already too high for shorebirds to stay. So in this kind of data, we can have a very precise water level data on how we can control the water level, and how we should control water level to allow to maximize the use of shorebird. And then this is another example from the data from September, that is in the summer or just the beginning of the autumn season. So the number would be much lower, but it gives us a similar idea on how shorebird would use our habitat, and how we can correlate with the water level. So here in September, we are using the prescribed flooding in this area. We push the water level as high as possible to over 1.9 meter. So the shorebird counts, there is no shorebird here. But then we know that they will use the alternative high tide routes. So this is as expected. They will use other location, like here we have 1.65 already, some of bird here, and 1.1 meter or 1.7 meters, and some birds here. But then still, there are some in other area that is not designed for as a high tide route. Some area that is operate as a traditional gateway, but then some shorebird will stay in those areas that are originally non-high tide roosting area, but they are using those areas. And then with this kind of information, we can even those traditional gateway, we can also control the water level to maximize the possible area that can be used by shorebirds. So because we are also like everywhere else in development city, in developed city like Hong Kong, we are also facing other development pressure outside of the reserve. So this kind of information, we can hopefully we can increase the capacity within the reserve, so that if we are losing wetland outside, hopefully there we can increase the capacity within the reserve, so that the shorebird can be benefits from this kind of more precise and more dedicated management. So this gives us the basics for the optimal water level evaluation for the water birds for each gateway or point within our reserve. So this is.
Ivan, sorry, but we can give you 2 more minutes.
Oh, all right. Sorry. There's so much that I can share with you. So like the performance, where are we? So yeah. We can also reevaluate the performance of water level control, like how whether the water level is how much time will they fall within our optimal range. Like, for example, these are the flooding area. These are flooding for the flooding, and these are the green area is for the optimal for shorebird standing. So the red area is already too high for shorebird. standing or the purple area is too low, too low. The water level is too low. And then when we minus the time that we carry out the water exchange, we can have some number, and we can have an overall number that we have overall 60% of the time is within the optimal range. And then out of those, 20% are too low for the optimum, the water level is too low. So in the future, we can look into more details on how we can more precisely control our water level. And also these are the buffalo data, like we can compare the daytime and nighttime data. We can look at how they are using different kind of area. So this kind of a summarized slides that how the IoT system can help different teams for the management and for the research monitoring. And here are two more other examples, because those previous cases are only the very first smart wetland project. So actually there are quite a lot happening within Maipo Natural Reserve right now. So for example, here we have a Pentil Zoom high resolution camera. We can check the camera at home, the image at home, and this image is the night we check when we check the camera at night. We found that the blackfish spoonbills are using our high tide routes as the night routes. This is very new to us because before this kind of IoT installation, we didn't check the high tide routes at night. But then the Pentil Zoom camera can allow us to have this kind of information. So we can also explore this Pentil Zoom camera in the application, like for surveillance purpose, or and also to explore the AI AI identifications for wildlife monitoring and research purpose. And also another aspect is that we are upgrading our camera trap system for the mammal monitoring within the reserve. For example, the Eurasian otter here, the camera trap, the smart camera trap here, successfully identify this Eurasian otter. And this can also send us an alarm that an Eurasian otter appears in that location. And then it actually leaves some poo-poo here, is some otter springs here. And then the following days, we can go check the location and collect fresh otter springs for the otter. And then we can carry on some DNA analysis for the otter. So here are just rush and glimpses of what we are doing in the wetland. And actually there are quite a lot happening, and very much a lot to follow up on all these kind of IoT applications. So I think this is all what I want to share. And if you want to go into more details on the buffalo tracker or the water level sensor and water quality, you can go check these reports that is published online. And also for the future updates on any smart application, you can also follow our social media, and we will update regularly. Yeah. So this is I want to share, and thank you.
Thank you so much, Ivan. Although there is no one-fits-all system, but still this IoT shows us like exciting possibilities of using innovation in our work. So going to move on to the question. Is anybody having question?
Aram, I'm going to
Yep.
jump in with a question on behalf of Hunya Choi, actually, because she's having difficulty putting it into the question box.
Sure.
And she's put it to the WhatsApp group.
Sure.
So she asked, have you encountered any challenges in interpreting IoT data And how do you ensure the accuracy and reliability of the raw data collected?
Oh, yes, thank you for the question. And actually, the reliability, yes. So that's why we have to carry out a lot of ground truthing and also from, for example, from this kind of data, actually, when we see some of the fluctuation like here, we always have to go check what is the problem. And sometimes, one time there is a spider that's high in the water level sensor, and then there's so much happened during the installation or the data collection period, and also we have to manually cross-check the data as well. So, for example, the water level sensor, we also carry out the manual checking. We collect the data manually as well to check the data as well. So we carry out a lot of cross-checking, and in some case, for example, in the buffalo tracker, we before the deployment on the buffaloes, we actually put them outdoor in a stationary on a desk to check whether the GPS would float, would jump to an extent that is not acceptable. So we do this kind of ground truthing and data checking to ensure our data reliability. Yes, yes, we did some of those works. Yeah.
Okay, thank you very much.
Adam?
Yeah.
In the WhatsApp chat room, there are complaints that they cannot access to this chat box. I mean the Q&A box.
Mr. Sa, I will manage this. So Adam, you can go.
Okay, okay.
Okay, thank you. Now I can see the question from Mr. Nurazmil. He said that truly inspiring works in MyPool. Congratulations. A question on the AI identification on camera trap. Do you establish that yourselves, or does the identification reliable?
Oh, thank you for the questions. Yeah. For the AI identification in the camera trap, actually we obtained this identification. We recruit a vendor to provide the service. So it is a kind of a package they will provide the camera, they will provide the because of the AI and also the online management platform or the camera. And you can treat us like we go to the supermarket, we buy a toy, but then we customize them. Because we have to train them, we have to train the AI because even though the AI is trained when they are on the market, but those they have to adapt to our environment, like because every wetlands or every reserve, they have a unique environment, and the cameras need to adapt to that environment as well. And also we have to give them the species list so that they won't identify a domestic dog as a deer like that. So because there's no deer in Hong Kong, obviously. So this kind of customization and training is needed before we can very confidently apply this AI to the outside. So actually, this project is still ongoing. So it is just a few months old after we deploy the camera. But then this otter already appears, very fortunately, because otter here is very rare, extra rare. Like they just come and go from time to time. So this is very lucky for us to have a case like an otter appear and the AI correctly identifies them. So this is very lucky.
Okay, thank you very much, Ivan. And I want to say, Doje, thank you again for that engaging presentation, and to everyone who asked questions. Okay, next we will hear 2 case studies showcasing technology and community engagement in wetland monitoring. If you have any questions, feel free to drop them in the Q&A chat box. First, let's welcome Professor Ivy to share her insights. Professor Ivy, you have 20 minutes. Please go ahead.
Thank you. I'm just gonna start my clock. Is my screen clear?
Yes.
Okay. Good afternoon. I think I should say good day to everyone because we are at different parts of the world. Okay. I'm here. My name is Professor Ivy Marlambio. I'm a professor here at the University of the Philippines, Los Baños, but also a trustee of the Society for the Conservation of Philippine Wetlands. And I would like to present to you this today, one of our activities involving how to monitor and survey wetland ecosystems. So I'd like to introduce to you the Wetlands by Blitz project. It is it's a means of monitoring Philippine wetland ecosystem. Okay, so the Philippines, despite it being a small country in this part of the world, is actually made up of around more than 7,000 islands. But within these islands, we have a vast array of wetland ecosystem. In fact, more than half of the wetlands that we have are actually lake ecosystems. Okay, so lakes and river ecosystems, and a little less than a fourth of the wetlands that we do have would be of marshes, peatlands, as well as mga water storage area. Okay, so the Philippines, okay, would have one of the largest lakes in Southeast Asia. In fact, it is the 3rd largest lake in Southeast Asia, which is Laguna Lake. And our university here, I teach in the University of the Philippines, Los Baños, is actually situated right next to the lake. So part of our classes would actually be going into lake ecosystems and trying to find out the hydrology, the biology of this next door neighbor that we have here. So Laguna Lake is quite a big lake. It is around 911 square kilometers big. Okay. It is fed by 21 tributaries. So there are many rivers that are actually feeding to the lake itself. And it has one output. You might know of the Pasig River that passes through our capital, Manila, and it drains to Manila de Bay. Okay, so that is the main outpour of the area. But this lake ecosystem is right next to the metropolis. Okay, so there are a lot of pollutants brought about by anthropogenic activities that are also brought into the lake ecosystem. It has been historically known to be providing a lot of services for the people that are surrounding it. Therefore, it is heavily utilized. Right? Right now, the current depth of the lake, it is only average around 3 meters in depth at present. But this lake is actually a remnant of the once active Makiling Mountain. Right now, it's a dormant volcano, but it is actually a very active volcano that had erupted several years ago. Therefore, when it collapsed, formed the caldera, and it is now a big lake, but it has been, over the years of siltation, has already been, is now very shallow, around 3 meters depth all throughout. There are some areas that are quite deep, around 20 meters deep, but on average, it's around 3 meters deep only. Okay, so it is a good area for fisheries. Okay, so there are a lot of pens in that area. It is also means for recreation. So because of this, there are a lot of anthropogenic activities that are being done here. And one of the other anthropogenic activity that is being done right next to lake is agriculture. So a lot of the pollutants of the lake are actually agricultural pollutants. So to sustain the lake, to extend its ecosystem services for a longer period of time, there are actually several agencies in the Philippines that are actually looking into how to properly utilize this different wetland ecosystem. Laguna Lake being one of the closest to the metropolis, right? So of course we have a government agency devoted to environmental management. This is the Department of Environment and Natural Resources. Okay, and within the DNR, we have the Diversity Management Bureau. So this bureau is actually in charge of looking into how rich our biota here within the Philippines. And if you look closely at the organizational structure of the BMB, there is actually a section there that is devoted entirely just to monitor wetland system. So this is the Caves, Wetlands, and Other Ecosystems Division. Okay, so out of the many bureaus, okay, within the DNR, there's actually a sector that is devoted into monitoring wetland ecosystem. Okay, but even with this, there are still a lot of hurdles and challenges that this government agency is looking into or experiencing. Therefore, some of the wetland ecosystems have to be allocated a separate agency that would actually monitor it. So take, for instance, Laguna de Lake. Aside from the DMD, the Caves and Wetlands Ecosystem Division looking into it, there is actually what is known as the Laguna Lake Development Authority. And this mission of this agency is to manage and develop and transform the Laguna de Bay region into a vibrant economic zone through conservation of the lake. Okay, so we look into conservation of what is in the lake and what is surrounding the lake. Okay, look at basin resources, look at how good governance with the participation of stakeholders would enable us to keep the lake intact. Okay, so not only do we need to look into conservation of biodiversity and water quality and the likes, but also we'd have to look into how it can be a source of resources, okay, an economic source for the surrounding areas, right? So because if it is a big lake, there are some agencies that are actually doing lots of research in it. Even the University of the Philippines would have many researches that would be targeting how to improve water quality, how to lower or identify invasive species, how to look at land use of the different areas surrounding it. It doesn't help that it would help that we would have other means of educating the stakeholders so that they would also be the ones involved. Yes. So the Society for the Protection of Conservation of Philippine Wetlands devised a citizen science type of approach in educating local communities on how they can also help in the monitoring and utilization of the lake itself, right? So what the members of the SCPW did was adopt a strategy that is not really new to biodiversity conservation. This is the BioBlitz program. I think, if I'm not mistaken, was first introduced in the United States, but was adopted by several European countries, right? And I think in one of the WLI activities, our executive director, Ma'am Ami, talked to a person who was actually doing the BioBlitz program. But the BioBlitz program is designed for a species listing. Okay, so usually it is an intense program wherein experts would come in and they would help the local communities make a listing. So how many birds will they be seeing in 24 hours? How many plants that they will be seeing? They would have binoculars and capturing devices or photos like that. Okay, so it would be composed not only of the volunteers and the students in that area, but a lot of experts will be invited to that area. All of them would be in a tent with microscopes and materials that are there. And the society said that instead of having it as a whole biodiversity survey, let us try to cater it into a smaller community targeting wetland ecosystem. Okay, so what would be our objectives here? So the first one will still be retaining the use of yung biodiversity. Okay, so as I mentioned earlier, it isn't new for the Philippines. Okay, so these are some photos of other groups that are doing BioBlitz program. You have from Singapore, the photo here at the bottom left-hand corner is actually butterfly monitoring. So 24 hours of just looking butterflies. For other countries, they would be looking in, let's say in other insects. Some would just be looking at birds for that. Okay, so 24 hours of intensive activities. In the Philippines, when we adopted it, we called it the Wetlands BioBlitz program, and our theme was to have an active, clean, and bountiful wetlands. Okay? And the general objective of the BioBlitz program was to characterize and prioritize river ecosystems, okay, using what is known as citizen science. So again, we'll be using local stakeholders, since they are the ones that are in the community, they are the ones that are always there to monitor it, to help them increase their awareness of what resources that we have, and at the end of it, to capacitate them, okay, to have action plans on how they would be conserving that area. Okay, so specific objectives would be to identify flora, fauna, and other biota in river ecosystems. Okay, but aside from this, the first objective is very similar to that of the BioBlitz program that is being done worldwide. Okay, but for this specific BioBlitz wetlands, we also would like to learn about river ecosystems, what are the benefits of these river ecosystems, and how to have initiatives to manage and conserve them. So we're actually incorporating here some of the objectives that we have identified when we do the Ramsar on ecosystem services. Okay? So we actually have surveys on using the RAWES, or the Rapid Assessment of Wetland Ecosystem Services. Then, aside from doing biota, aside from doing our RAWES on it, we also allow the participants to be the ones to create their action plans. Okay, so to operational a citizen science-based strategy in the rehabilitation of the selected rivers. So instead of just scientists going to that area and doing their study, and after which they'll be publishing it in papers, okay, and the scientific community would be the ones that would benefit it, what the society, and it is still being done, we complement it with the citizens themselves being deeply involved in the data collection, the recognition of the species that are there, okay, and they can also keep the data such that they can continuously do, I've already seen this bird, it has already been introduced to me, or this plant has been identified, let's say, as a bioinvasive species. So you can monitor how far would be the extent of their distribution, or how are we going to take them out of the ecosystem so that local biota would be flourishing in that area. Okay, so we do have, for each time that we do the BioBlitz program, we do still invite a lot of the scientists or experts. So we would have experts on flora, okay? So plants, be it higher vascular plants or yung lower vascular plants like mosses, okay? More often than not, we have faunal assessment, but mostly on avifauna. Wetlands ecosystems are known for yung wetland birds. Okay, so we usually have a ornithologist with us to help us monitor the aviflora in that area. In some occasions, we do get to invite herpetologists or sometimes mammalogists for that data, for data collection, and that is most welcome. Okay, but also we look into invertebrates. we invite a lot of entomologists here. So the participants would not only, they can also be looking at food chains and food webs that are happening in the community, which since our participants would be high school students, they can actually relate it to their school activity. This one eats this one, and this is what we are seeing in our different ecosystem. So invertebrates, mostly arthropods, so insects and spiders. But sometimes we do get a malacologist or a snail expert, okay, or a worm expert that would also join us in our. For microorganisms, we have a vast array of microorganisms. We do invite a microbiologist to join us, but we do sampling of plankton. Right? We know plankton composition would change different types of wetland ecosystem. So not only would the students be allowed to use microscopes to view these tiny jewels of they appreciate the reason why this wetland ecosystem is green in color is because of the algal blooms that they see. And they would be appreciating it more. We'd also be looking at pollutant indicators. Sometimes you get microcystis in the water. So that is a good way of educating. Your water needs to be filtered, okay? Or you need to do some changing of the biota such that the microcystis would lower in numbers, okay? So more or less, these are the different major taxas that we invite, or taxas or experts of these taxas that we invite to do the BioBlitz activity. So this is the biota of it. But since this is wetlands, we also incorporate other basic parameters that is important for wetland monitoring. So since we are doing river ecosystems, the basic profiles of the river, how wide, how deep, what is the pH of the water, what is the source of the water. We look at hydrology, so we also do water quality. Okay, we do measurements of phosphorus and nitrogen and likes. These ones are done in the laboratory. We can't do it in the 3-day activity, but after we do the activity, we send it to the laboratory. Then we also give it back to the stakeholders for them to appreciate. Our water has high pH, high pH or low pH, or the phosphorus level is quite high, probably from the agricultural portions of that area. Then one group would usually be involved in the survey. Okay, so we do the rapid assessment of wetland ecosystem services with consent. We ask the local communities first, can we have a survey along the river ecosystem, whoever farmers, households that we see there, and how they are utilizing these different river ecosystems. So we know what would be the sources of pollutants, what would be the sources, or what would be the activities that are being there, so that we can add that to how they are going to do their action planning. Okay? So these additional parameters are what is different from the normal BioBlitz that is being done worldwide. And this is what we are trying to also share to you that you might also would like to do in your different countries. Okay? So if the normal BioBlitz program is only a 24-hour activity, only one day, what we do for the Wetland BioBlitz is actually a 3-day activity. First one is leveling off. We have learning sessions because the stakeholders that we are targeting here are high school students. Okay? So we have a half-day learning sessions. We teach them how to do data collection. Then we teach them how to process this data, the short version of it, so that they have some limited knowledge on how they're going to monitor it, even if we already get out of that ecosystem. After we have gone and are done with the 3-day activity, they can continuously do it. Then, after they have processed their data, they are the ones who will do the visioning and action planning. Okay? So we will not tell them, this is what you're going to do, this one, because each locality would have their own objectives, right? So they are the ones who would be visioning and making their action plans. Okay? So these are just some photos of the activities that we have done. So you'll notice that there are some municipalities in the Philippines that high school students have no access to microscopes. We actually bring them there, and they are quite amazed by seeing this little gadget that can see small things. Okay. even if the water is only knee deep, we ask them to wear life vests. So they also know of the safety procedures. We allow them to use binoculars so that they don't only see the Eurasian tree sparrow. Instead, they would see a variety of other wetland birds in that area. They don't appreciate it until we actually tell them, "Hi, this one is a wetland bird and it is only found here in this waterway system." Okay, so we allow them to do the activity, to appreciate them, and hopefully ingrain in them how biodiversity is important, and that they will be the ones that will be continuously monitoring it. Okay, so far for the Laguna Lake, we have out of the 21 major river tributaries, we have done 3 so far. The Pangil River, we also have the Lumban Pagsanghan River and the Babitak River. If you notice in the pictures here, for the Pangil River, the water is clear because it is more pristine. While for the Lumban and Pagsanghan and Babitak River, these are 2 municipalities that are heavy in agriculture. So you'd see that the water is a little bit cloudy. Okay, this one has a lot of siltations that we see, and the students would part of our learning activities during that is telling them why is this happening. Okay? So aside from these 3 tributaries in Laguna Lake, we also are targeting or utilizing the BioBlitz program in other wetland ecosystems. So the first one is the Las Piñas Parañaque wetland. This is the last mangrove area in the Metro Manila. Okay, and if you have seen our news, this one is also being threatened right now with reclamation. Okay, but hopefully the government would understand that this wetland area is a very important site. Remember, it is a Ramsar site. It is a flyway for birds ecosystem. But aside from the birds, the biota here is what is actually safeguarding Metro Manila from further being damaged by typhoons and floods and the likes. Right? And the last one, our pet project here is in Candaba, okay, which is in Pampanga. Not really a Ramsar site yet, but it is an important flyway zone, and it is a breeding ground of a lot of species. But because it is in the middle of the agriculture ecosystem, is being encroached in changing landscape into agriculture. So we are trying our best that there are some areas that would be delegated for wetland conservation, for nesting sites for birds, and to conserve that area. And to help us monitor it, we're doing the BioBlitz program there. And here, our stakeholders are the farmers and cooperators in that area. And hopefully, we are successful in teaching them that this area, despite it being like barren land to them, is actually a source of their livelihood in that area, because the birds that are going there is actually the one that is safeguarding biodiversity equilibrium in that area. Okay, so aside from that, I mentioned earlier that we do have other agencies, like government agencies, that have projects in it. But at the same time, we are also being asked, the society is being asked to teach them. Okay, the Caves and Wetlands group are sometimes being asked, "Oh, how are you doing this activity? How can you augment our government efforts?" So sometimes we have training of trainers from the BMB to teach them, we can do this, so that even if the society is not there, they would be the ones to introduce it to the different communities so that they can continue with the BioBlitz program. Right? And here are some pictures of the Paligid wetlands. This one is in Candaba. And what we see here are farmers, right, that are being taught that, what birds are there, what animals are there, right? And because these are members of the local government, these activities can actually be utilized by local government agencies for getting yung seal of approval, good governance seal for this municipality, because they are looking into biodiversity. And that is a plus factor for them if they're able to have nice biodiversity surveys to add to their assessment of that area for land use flex.
Sorry,
Okay.
Professor Ivy, I think we can give you 2 minutes.
Okay.
Yeah.
No problem.
Sorry.
So aside from that, I said, we do action planning. So these are just some of the outputs of them. These are done by the high school students. These are RAWES sheets here that they are able to assess, right? And from this, what do they do the data? We give them their data. Some of then the data, we have copies of them, which we upload in our website, right? So in the event that we would like to go back to these data, they can actually access them. Okay, so it isn't ours to keep and ours just to publish for ourselves, but instead they are able to access them. They can take pictures and put it there. So it is citizen science of just taking pictures. Even if they're not able to identify them, they're able to, can you help us? What is this bird species or what is this plant species? So you connect it with experts that are remote in that area, and they are continuously being encouraged to look at biodiversity. Aside from that, we have a lot of knowledge products here, like action planning outputs. We do have the website itself. And for each BioBlitz activity, we do give them a manual on how to do it so they can continuously do it after. Right? So what are some of the advantages? So I can summarize. First, the stakeholders do the data analysis, gathering and analysis. So they are the ones who do the action planning, right? And after we are done, they can continuously do monitoring, right? So they have some prior knowledge on how to identify this so they can be the experts in their field, okay? Then because the data is uploaded, the repository ensures long-term data availability for them, okay? And as I mentioned earlier, some municipalities use the BioBlitz activity for applying for their seal of local good governance certifications, okay? Then they are the ones who are able to craft wetland management plan. A few disadvantages would be because the stakeholders are not experts. Sometimes it would take a long time for us, for the society, to congregate some of the scientists and go to these different areas. But I think that can be solved over time, okay? On how are we going to ensure that the scientists and the experts will be going there. And instead of the 24-hour duration, since our target audience are actually kids, we can't do night surveys, okay? The parents won't allow us to do that. So some of the biota, like mammals that are nocturnal or birds that are early morning, we miss out on that data set, okay? But over time, depending on who will be the participants of it, we can actually augment it later on, okay? So this is what we are doing here, and I hope it continues for more river ecosystems throughout the Philippines. Okay, so that will be all. Thank you so much.
Thank you very much, Professor Ivy, for the valuable presentation on community engagement via citizen science. Now let's continue with our next case study, Dr. John. He will share how drone technology is used to survey species in wetland conservation. Dr. John, you have 20 minutes. The floor is yours.
Kia ora, good evening, everybody. Or good evening for me, perhaps good afternoon for many of you. Yes, I'm a trustee of Matuku Link. By the way, are you hearing me well? Am I loud enough?
Yes.
Yes, you can hear me good. So Matuku Link, can I have my first slide, please, Ion? So if you can present the first slide. I think you have access for me. You were going to present the first slide. Right. That there is a picture of our wetland. Matuku Link, the project, is situated west of Auckland City. Auckland is New Zealand's biggest city. Unlike some of the other presenters, we are a non-governmental organisation. Basically, most of the activities performed by volunteers, community people. Matuku Link was established in 2016 and we joined WLI last year. Our aims for the project are conservation of existing indigenous species, and in the New Zealand context, that usually means trying to get rid of exotic invasive species, limiting them or eradicating them where possible. So restoration is the second aim, and we have established a nursery to grow plants to convert what were previously grassy paddocks into flood, and it's not a floodplain, back to the sort of indigenous wetland flora that once would have been there. Our third main aim is education, and education about wetlands and water values. And we currently have a couple of paid staff who are teaching children mainly at the elementary school level. We do have various special nights of bat monitoring, fungal forays, invertebrate nights, etc. So that's it. And you see us there. We've got two main wetlands that we are interested in. The one in red there, the Tahenga wetland. Tahenga was, until the late 19th or the early 20th, a dune and pounded lake. And then in the early 20th century, with the construction of a large water reservoir, a lot of farming, a lot of felling of native trees, it silted up and became a wetland mainly full of reeds and rushes. Then more recently, with other exotic weeds coming into it. The wetland further down on Whatapu is more a coastal wetland, and even just over 4 or 5 decades ago was considered ephemeral wetlands, but with the north current bringing sand continually up on that western coast of New Zealand there, and the diversion of one of our large creeks, what were ephemeral wetlands are now permanent, and you'll see a photo of that later. Next slide, thank you. So wetlands provide complex, multi-layered and ever-changing habitats that can sustain a diverse range of species. However, the complexity makes monitoring those species incredibly challenging, as they're often difficult to access, even harder to observe from a distance. Traditional ground-based surveys are often spatially limited, while manned aerial surveys can be too costly for grassroots community restoration programs. On the other hand, unmanned aerial vehicles, drones, that provide cost-effective solutions that could put critical monitoring tools into the hands of communities on the ground. So that's us. We are non-governmental, relying on funding that we gain from various ways. So our first species, the use of the drones, and we over the last 8 months we've had to have done 3 distinct things using drones. So our first one here is using a UAV for Pārteki, a brown teal, an endemic species. It once was the rarest duck in the world, fewer than 600, but it's now 2,000, perhaps 3,000, at risk recovering as its IUCN status. But we translocated this duck to this wetland, the Tahenga wetland, in 2015 and 2016. How are they doing is the question. And the particular wetland has got quite a complex geography, lots of open water, lots of reed beds, tree species in there as well. It's got some of the surrounds to the wetland, very steep slopes of densely vegetated forest. There's some farmlands with limited access allowed. There's some native forest, which unfortunately in New Zealand we have a fungal disease affecting one of our climax canopy trees, and so there's restricted access. So it's very hard to get around this wetland to do any surveying for this particular duck. So I came up with the idea of, if we can't go around, then let's go over the top. And so Dr. Rebecca Rogers there from a local university, the Auckland University of Technology, is helping us out. And next slide, thank you. So this just shows an aerial of our wetland area and some of the flight paths that she has done to fly over and start seeing if we can get some sort of a census. We know just from anecdotal observations that we're seeing young, we're seeing some dispersal, but as to numbers, it's rather hard in this with this complex wetland. Thank you. So this is what we're looking for. We've got a pair on that left hand. On the right hand photo there are 7 of these parteki. Now, one of the problems, of course, using a UAV is how close can you get to define what you're looking at, to see it, to detect it? But how far do you have to be before you disturb the species? The photo on the right was taken at about 15 to 20 meters. The drone was only 15 to 20 meters above. And one of the birds casually lifted its eye and looked at the drone. They seemed nonplussed, which may explain one of the reasons they became so rare. A duck that was found throughout the country and now down to about 600 birds in 2 sites in the 1980s. They're naive, as most of our wildlife was, because, of course, New Zealand had no land mammals until humans came about less than 2,000 years ago. So these birds were naive. They're not aware of some of the threats that other birds that are more exposed to predators are. So there we go. Yeah, next slide, please. So these are some of the problems and difficulties that she's found. So visualizing the UAV as it flies at lower altitudes. We've got requirements here, as possibly other places, that a drone must be within visual sight of the operator. So at lower altitudes, though, with the hills around, you sometimes lose sight of the drone, even though they've all got flashing lights. So that was an issue to keep the thing in view. Resolution of the imagery, being able to work out how high you could go to actually pick up the target species and without going too low to disturb them. Access to launch sites is another issue. And then finding time to review the imagery. And I must admit, we're still waiting on some of that. But Dr. Rogers is going to be doing this in the future as well. So we'll be able to look at more of the ponds and get more of an idea of our population of this particular rare duck. Yeah, thank you. I'll move on to the next. So then we had the Matuku Hurepo, which we name our project after Matuku. Matuku is the Australasian bittern, or in Maori, it's Matuku Hurepo. And, you see in status as vulnerable, but it's nationally critical in our classification, and possibly fewer than 800 throughout the whole of the country. And this, again, was a bird that was found throughout almost all of New Zealand, but New Zealand, in a very short time, has lost over 90 to 95% of the wetlands that were there pre-European times. So here we had a different way to survey for a different species. This is a cryptic bird. Its feather pattern, as you see, enables it to blend into reeds and rushes very well. So it's designed to blend into that background. It doesn't want to be seen. But it's also a highly mobile species. It clocked in at going, easily to 300 or 400 kilometers. It's highly mobile, and breeding season is a time that it's more likely to anchor to one site. And it's that time that we try and find out how many are breeding. And we're judging that on the males up to now. The only way to assess these birds was to listen for the male booming at breeding season. Then sort of guesses were made as to number of females or non-breeding juveniles, but occasionally you might see fledglings, but it is very hard to detect this bird. So next slide. Well, here's a photo, by the way, of the other wetland, more of a coastal wetland, as you see there. That's a bigger area than the first wetland we're talking about. Thank you. Next. So in about 10 years ago, I had an association with a drone operator whose main job was actually sending drones into disaster areas, tsunami, earthquakes, looking for survivors and helping out in that way. I noticed that he used thermal cameras on his drones, and I conceived the idea of using a thermal camera to find bitterns from the air, because in the midst of reeds, they're very hard. And so this is the sort of thing that is now possible. When we did this, we did a trial with the Department of Conservation's bittern expert in another part of New Zealand. At that stage, we had one drone with a thermal camera, and we followed it shortly after with a second drone that had an optical camera and tried to match the images. And we learned certain things about the optimum time to search for the birds. But the whole idea was let lapse for a while. But then more recently, you can get off-the-shelf drones that have both thermal and optical cameras in the one drone. So this is the sort of thing that you'll see from such a drone. The left-hand image, thermal there, the white spot represents a bittern. A bit harder to see on the right hand, but a sort of a stellate pattern there, which is the path that the female who has been sitting on the eggs takes at different times to go and feed. Okay, next one, thank you. So on the Whatapu coastal wetland, they thought they'd found a bittern nesting, went back later in the day with optical cameras and found, unfortunately, it wasn't a bittern. It was another more common species, a kahu, a harrier hawk. These hawks have, in fact, increased in numbers greatly in New Zealand since land clearance and that, so it favours this bird. It's also become a predator for the bittern. Yeah, so we then move on. So with the thermal drone, although the aim had been for the drone operators to go over both of our wetlands that we are interested in, it was new technology for them. They had these difficulties, so they only were able to go on that first coastal wetland. It was a large area to survey for potentially very small numbers of the target species. The reflectivity and non-animal heat signatures that increased after sunrise was quite a problem. It allowed only some 3 hours in the morning to be able to do the flights. After that, the reflective or radiant heat from rock areas and the vegetation sort of made life difficult. So they did do some dusk flights and some night flights, and any sort of thermal signatures of interest they picked up in those night flights, they would then go back in the day and see what they'd picked up. And that was the case for that other species that they found. And then so there's the main issue that the drone operators found there was that there were strong thermal signatures from the highly reflective vegetation and water surfaces. And that's not just the radiant heat that builds up as the sun comes up. It's also the albedo effect that you get a straight away sort of a heat reflection. So this, we didn't get to both wetlands that we wanted. This group is from our local regional council. They will be, Yorken Council, they will be doing this again for us. Next slide, please. So one of the things we hope to use next year is to help to focus the drone activity by this land-based human listening. This map here represents something that was done this year at our wetland as part of a nationwide survey at specific times to try and get an idea of the metrics of this bird, how many males were booming throughout the whole country. 3 specific times in September, October, and November, which for us is our breeding season. And so with data like this, we would say to the drone operators, well, this is the region that we figure you should be concentrating on. So this might be a better way of indicating possible nest sites. Our final use of a drone was with a herbicide spraying for an invasive exotic species, a crack willow, Salix fragilis there. The invading willows replacing reeds and the Typha orientalis habitat, which reduces the breeding sites for the bittern. Particularly the Typha, the bulrush, is the prime habitat for breeding for this bird. Manual means of drilling, then herbicide injecting are time-consuming, they're dangerous to operators, and they utilize excessive herbicide. Sometimes the operators would have to be in chest-deep water to be able to drill into the willows. There's a greater potential for spillage from the operators who are working in these awkward conditions. And the spraying from with aerial means is far superior. So UAV, a cost-effective way of eradicating willows. In 2023, just after we had made our application for funding for this particular eradication, there was extensive flooding in our area, affecting human infrastructure, knocking out the one and only road to a community with landslides and slips, houses being damaged, other buildings being damaged, cars and such covered with silt. So willows do what willows do. They build up silt and debris under their trunks, their multi-stem trunks, and that helps raise the water level, and then you get inundation, which raises the water level even further. So as well as a reason to improve the habitat for the Australasian bittern and other wetland birds, there was a human reason to try and get rid of them as well. So then we had a commercial operator do initial photographic mapping, and then followed by the herbicide spraying. So next, thank you. So this is an orthomosaic, over 2,000 photos taken to generate this picture. At larger magnification, you'll see just individual trees of the willows, and it's that was used then to guide where the flight paths for the spraying. Thank you. But there were a lot of challenges for our herbicide spraying. So there was all those legal issues, various agencies, health and safety in the workplace, dangerous goods, etc. Access. Some of the drone would have to leave from, I think they used about 5 different sites to cover that whole area. And many of those were on private properties, difficult roads or tracks ready to take large water tanks down. Records had to be maintained, flight heights and weather conditions, wind speeds. Wind speeds greater than 15 kilometers an hour meant that the drone had to stop. And we had in New Zealand and perhaps Auckland particularly, we do not get long periods of stable, calm weather. So it took quite a while to get enough days to do the job. So then civil aviation authority issues, all those listed there. Public scrutiny, because there's still, we had to face a little bit of antagonism from some people who were against spraying of any kind. So we had public meetings, we arranged that there'd be water testing. We were using glyphosate. And so we tested the water, which showed, of course, no glyphosate. and we will be doing post-spraying studies. The funding we got from our Department of Conservation was considerable, but it was for over 3 years. So as in all of these control and eradication, you get the majority done in your first year, then you try and get a portion of that, a good percentage of that the second, and hopefully by your third year, you're down to minuscule or zero. So there will be further spraying, mopping up mist areas. The bulk has been done, the large groves, but there will still be individual outliers and single trees that will need to be taken out. Thank you. And then, so that gives an idea, the grey-brown picture there, some of the groves of this invasive willow. And some of the residents there have observed over 20 or 30 years how the reed beds have just been taken over by these willows. Photo on the right there of the large agricultural drone. It uses a blue dye to indicate where it's going. That I think is perhaps more for observers. After all, it's on a flight path that's directed by the information you've got in the past from all those photographs there. Although it is under visual control, and the operator was able to avoid any particular stands of indigenous trees that we wanted to keep, of course. And then this a multispectral photo, the red and the dark red and orange indicating the dead willows. The green area is still some more of the indigenous vegetation we want to keep. So yeah, that's gives an indication of how precise this can be, just small areas. And then with the canopy of the willows gone, our native species can flourish. We did some 90% of the whole wetland in 20 to 25 flying hours. But as a concession to two particular private owners who were not wanting any spraying near their properties, we agreed to do the manual drilling and injecting. And that final 5% we got took about 3 weeks, putting a group of people at risk, as I say, in deep water. You actually use more of the herbicide because it has to be a far greater concentration. It's quite a task to do this in this environment. And that, I think, is our experience with using drones over this last 8 months. And all of those projects will be repeated in the next year or two to get more information in the case of the bird surveys and to finish the job in the case of the herbicide spraying. Thank you.
Thank you very much, Dr. John, for the fascinating case study showing the potential and also challenges for using drones in wetland work. And many thanks again to both of our case study speakers for their wonderful insights. And to participants, apologies for technical issues with the Q&A chat. We may have more engaging Q&A time during the open forum. And we are moving on now to the last segment, the open forum. This will be a more interactive session. So please share your thoughts and reflection on today's topic, or even you can say what you expect from the WLI Asia-Oceania network. And Mr. Sao?
Yes, this is a pure question from the from the great presentations for the learning session and case studies. Ivan, in your presentation, there was a question from Asmil. How did you develop that AI program to identify the otter with the video images? So we have the drone experts, I mean, they can create great images of birds or animals or vegetation. So if we can train the AI for the monitoring, then maybe we can automatically just shoot the drone on one end, and then on the other end, we just machine can analyze the monitoring data. I mean, would that be possible? Just a question.
Yeah, thank you. Thank you. This is a very good question because actually there are some places in China or some other places that are already doing this drone monitoring, and we are already identifying AI identifying species, all kind of species, except just not only mammal. They are identifying birds. They're developing this kind of AI model, and they are applying to all sorts of imagery, just like drone images or just like those high resolution cameras. There even if from monitoring and survey perspective, they are doing the monitoring, they are testing it out, but sometimes they are not quite reliable at this moment. But I'm sure the AI learns very fast nowadays. So maybe some years in the future, they just carry out the monitoring and do the bird counts. And also, I think it's quite interesting to use the thermal camera as well, so to test it out, to how they can carry out the bird count and bird monitoring as well. So, but one setback is that, for example, in drone monitoring or for those shorebirds that are very tiny, like the stings and plovers, there are still some limitations on identifying them. So maybe in the future, the camera resolution is much higher, increased to a resolution. Yeah, they're already doing this kind of monitoring. So this is.
I mean, yes,
yeah.
very good answer. But
Yeah.
one more question. I mean, if you are doing training your AI for the, I mean, you have done it for the otter with the, I mean, you purchased like a commonly, I mean, more generally designed, generic design of AI, and you just applied it. I mean, you trained it for your purposes, your own purposes. I mean, if this cost is not very high, maybe WLI Asia-Oceania members can utilize them. Maybe we can organize one training session with the WWF Hong Kong for the WLI, another for the WLI members on that, how to use.
Yes, sure. That's possible. But first you have to have that kind of software, and
Yeah.
invest in that software.
Yeah.
In the first place, yeah.
Okay.
That's possible, yeah.
Thank you very much.
Okay, thank you for Mr. Saul and Ivan for the interesting suggestion. So now we can have like open forum. So as I said, anybody can raise their hand or just verbally comment what you expect from like WLI Asia-Oceania network, or even the comments or questions for the webinar. Thank you.
So yeah, as I left the message in the chat box, so we are now inviting all participants as a panelist, so you can turn on your camera and speak each other. So please don't reject. So we are inviting you to be a panelist, and most of them are rejecting. So please don't reject.
Sungbo, literally, you are rejected.
I think we also have some wetland centers which wasn't participated last WLI Asia-Oceania conference. So please be interactive.
Hello, Prabhakar.
Hello, sir. Good evening.
Good evening. Asmil, not coming? Dr. Chen?
Yeah, I think participants are not ready to open their camera. Yeah. So if you need to open your camera, and you
Songbo, we cannot hear you.
okay, so no need to open your camera. So, or if you want to just speak, then please raise your hand. Then we can allow you to speak. And also, earlier in the presentation from Ivan, there's one question from Vivian. So Vivian asked, not to Ivan, you, but Vivian threw one question to all of you, that anybody else are adopting IoT or artificial intelligence for the wetland monitoring. If there is any, then please share that if you are already adopting IoT or artificial intelligence technology in the wetland monitoring.
I have a question I can ask of, well, a statement for Ivan there. I was intrigued about the water level sensors, and although our wetlands aren't controlled in any way, it's just that they can have quite big floods, and the water level can raise easily 4 meters. And bird breeding is quite sensitive to that. You know, if those floods occur in the midst of breeding season, it can create a lot of issues. And so I'll be contacting, I think, to see how we might do those water level sensors. Not that we can control the rain or the flood levels, but it may give us an indication why sometimes the breeding system has been not as good, you know, and because we've noticed after some of the flood events, one of our species we try to monitor has been in far smaller numbers, but the reverse can go to that. Sometimes the water level's too low. That's for some species. So, and up to now, I've been aware of this and thought just in terms of a manual system, but something that could be done on a you know, remotely and regularly without human intervention would be, I think, rather interesting. Not that it'll say it's going to lead to us changing things, but it may explain things.
Yeah, thank you. Actually, for the water level control, I'm not sure if other wetlands have to have this kind of water level control, or have this practice of controlling water levels to this precise level, down to maybe 1 meter or 1 centimeter, like this. But in our case, because we want to maximize the use of possible area for the shorebirds to use every single inch of the land. So we want this kind of precise water level. And then water level sensors is just like the stage 1 of our plan. Like, because if you imagine there is a smart gate as well. So if, like what you said, you just remotely control the gate, the electric gate, just it can program it for the water exchange cycle, and also maybe pair it with some AI function. For example, if it can foresee a heavy rainstorm in the coming few hours, it can open the gate itself and then just lower the water level before the rain rainstorm come in. And this kind of more like a smart gate and smart solutions is what we are exploring in the future. Yeah. So, but of course, we got to have that kind of information from the observatory department first. Yeah, like the rainfall forecast and maybe the typhoon forecast or something.
Professor Ivy, you might have some opinion.
Well, we welcome other wetland groups to adopt, and we will be very happy to accommodate you and teach you how we do our BioBlitz program. Okay, so an engagement not only of us, but also the engagement of the community. Okay, so we do have the arm of the academe, but we appreciate government collaborations as well as non-government organizations. It's everybody's responsibility. So, and again, we're targeting the youth for this so that continues.
Leaders.
Okay, so we have a question from Asmil. Question
Yes.
for Dr. John. Are you using third-party software for the area mapping, or was it using DJI software?
I think I will have to check on that, but I think it would be the DJI software for that. I will check that and perhaps get back to you. Somehow we'll find that out. So I will find that out. So software for
Thank you.
I will get your details from
Yeah, sure.
And I have one more question to Dr. John. You use the drones. We also use the small drones, but the quality, the resolution of images is not really enough to use for the analysis. So, for the drones that you use, can you replace the camera, or you can attach other high quality devices?
Again, I'm a volunteer trustee with not too much technical knowledge. The person who did our the optical camera one there, she has worked in Australia a lot. She is a drone tutor. I understood that she had a high quality camera, but as to how that compares with something just off the shelf, I cannot. Would you like me to find out what that was, or?
So maybe we can do some research on that. Yeah. I'm just curious that you are using that already or not.
Yeah.
Hello.
For the purposes, it is sufficient for this particular species in this circumstance. So that we have only a small number of duck species, so it's not going to be much conflict there about what you're seeing. So the images of those ducks were sufficient to say it was a particular species, the target species. Yeah.
Yes, I'm just seeing that Robert is there from Bangpu Wetland. I know that Bangpu was hoping to get Ramsar site status. I wonder, is there any update on that you know of, Robert?
Well, nothing official, but I know the Army, who are the key proponents, have great hopes that it will be a Ramsar site before the end of the year.
Great. So maybe not in time for COP, but before the end of the year. That's great.
Yeah, so I think we'll see. For us, it's been a very long process. I think more than 10 years, more than 5 years that I've known about it. So we've recently become an Asian Heritage Park, and we've joined the East Asian Flowway. So there's lots of things happening, and hopefully Ramsar will be the next one along the line, so to speak.
Great. Good news. Good news. And actually, Robert, you mentioned a question there for John about crowdsourcing image inspection, and I just put a link in the chat to a website called Zooniverse, where
Right.
I know some people have used, and that's where, yeah, some people can do that. If you're aware of that, yeah.
Yeah, well, of course, AI is the big thing, but this crowdsourcing has been going on for some time, and it works reasonably well. And even the booming that John mentioned, I imagine that sort of thing can be done with AI and crowdsourcing as well. I know that in Australia they have listening posts now for lots of crabs and things, and people submit audio recording. Sorry, not crabs. I've got crabs on the brain. Sorry, frogs and other things that make noises in the night. Anyway, it was just an idea, and within sort of like John and his team there will have a look at the Zooniverse and the Galaxy Zoo and other things where people have done that sort of stuff in the past.
I'll just add, we in our wetland here, at the same time as we were doing the active human listening, we did have a whole array of automatic recording devices, and the automatic recording devices pick up sounds, but one of the benefits of the active human listening, it can be directional. Now, there are sort of programs that allow you to have pairs of recording devices, and they can sort of calculate things, but that's another bit of technology, another bit of cost for what is, in our situation, a volunteer group. But so the human listening, we could give estimates of the compass bearing and even estimates of distance. But there we go. On a particular night, I think we picked up, on one night, picked up 3 potential males. Looking at the automatic recording device records, though, there were 5 picked up on that night. So, you know, there are pluses and minuses for each technique, and ideally, you'd use both. And as I say, it was a coordinated thing throughout the whole country. And I mean, you know, it's a small country, we've got a longitudinal distance, and so we had people out on all weathers trying to listen to these things. So it's very much a community thing, initiated by us and the community, but then joined in by the official group, the Department of Conservation, etc.
We also have a question from Hyuna. She asked, like, there are 11 designated Ramsar sites in Central Asia and Uzbekistan. Do we currently have any network of collaboration with wetland managers in that region? What I knew that, like, one of registrant of today's webinar, she's from, I think, Mongolia, but I can't find her here.
And maybe Mr. So as well, there's a Ramsar Regional Center
Yes.
for West Asia as well?
There are 2 Ramsar regional initiatives. One is the Ramsar Regional Center for Central and Western Asia, and also another RRI Ramsar Regional Initiative is a Ramsar Regional Initiative Central Asia. There are 2 initiatives. So when we meet the RIs at the Ramsar COP, we will introduce this program, and we will invite them to WLI Asia-Oceania. Definitely. Thank you for the good proposal suggestion.
And Hannah, in case you would like to also approach the team in the Central East Asia, so if you are coming for the Ramsar COP15, the RRICA Central Asia initiative, they are also organizing one-side event during the COP15. So I think you have a chance to meet them if you are coming for the COP15. Thank you.
Okay, so if there is no more comments or questions, I think we are ready to wrap up. But Mr. Saw, do you have anything to deliver for closing remark?
Oh, nothing much. Thank you. I really appreciate all your active participation, and then also for the great presentations for the speakers. And I hope all the participants enjoyed this webinar. I mean, we can do any. We have a great of flexibility, as we can have this type of webinar or forum, a symposium, workshop. We can do whatever. So please give us your inputs, then we will try to do our best to make it realized. So please have a good night and then have a good day, some part of the world. So hope to see you soon. Some of you in Zimbabwe and some others in the following webinars. So thank you.
Okay. Before wrapping up, we like to thank you all, and also especially warm thanks to our excellent presenters for your time and expertise. And I just left on the chat the post-webinar survey, so please, please help us to improve our future events. And just a last note, we are recording of today's webinar will be available and uploaded on RRCEA's YouTube channel next week. And we will send you details once the recording is ready. Thank you and enjoy the rest of your day. Thank you.
Thanks, everyone. Bye.
Thank you. Thank you. Bye-bye.
Thank you.
Thank
Thanks.
you.
Bye.